Okay, there are 4 types of tools in ArcGIS, and each is designated by a different symbol. So the first one is built-in tools like this, like a hammer. These tools are built using objects and a compiled programming language such as C++ or the .NET languages. Israel creates these tools when authoring its software, and most of the tools in ArcGIS look like this. And there are some model tools, it's like these, Model Builder, the icon. These tools are created using Model Builder. A number of tools in ArcGIS are model tools. For example, some of the rendering tools in the spatial statistic toolbox. So those are the script tools. These tools consists of scripts that are accessible using a tool interface. When the tool is executed, a script is run to carry out the geoprocessing operations. For example, a Python script, an AML, macro language file, AML, or an executable file, a BAT or EXE. Most of the script tools in ArcGIS uses Python. And specialized tools, these tools are created by system developers. They can have their own unique interface that is different from a regular tool dialog box. These tools are not very common, although third-party developers may distribute their tools in this manner. Although these tools are created using different methods, the tool dialog boxes for different types of tools all look the same. There are also 2 categories of tools. System tools, these are the tools that are created by Esri and installed as part of the regular ArcGIS software. Exactly which system tools are installed depends on the product license level and the number of extensions. Most system tools are built-in tools, but a number of scripts and the model tools are also authored by Esri. Custom tools. These tools commonly consist of script and model tools, but built-in and specialized tools are also included. Custom tools can be created by a user, but they can also be obtained from a third party and then added to ArcGIS. When using geoprocessing tools, you may not notice which tools are system tools and which ones are custom tools because they are designated to work the same way. Once a custom tool is created, it can be added to a geoprocessing workflow the same way as any of the system tools. Running tools using tool dialog boxes. When you find a tool, you can open it by double-clicking it, which brings up the tool dialog box. So each tool has a number of parameters that need to be specified before the tool can be run. A tool parameter is a text, string, number, or other entry that tells the tool how it should be executed. The tool dialog box provides an easy-to-use interface for specifying these parameters. This includes browsing for and selecting datasets, selecting options from a list, and entering values. Most tools require one or more input dataset. Other common parameters are preset text strings called keywords. Although each tool has one or more parameters, not all parameters are required. Optional parameters have default values that are set with the tool. You can accept the default value simply by not changing the parameters or by not specifying a value. Default values for keywords are typically shown on the tool dialog box when it is first opened. So we're going to use the clip tool, for example. So not the slope. I have to go back to the clip. All right. So every tool dialog box has a help panel. It's right here. Hi help, show help. On the right hand side that provides useful information about the tool. You can switch the visibility of the help panel by using the show help and high help button that at the bottom of the tool dialog box. To get a more complete description of the tool, we can click this button to access the tool help page. We will look at the help pages in more detail in later. So the tool dialog box contains the parameter that needs to be specified for the tool to run. Notice that there are a total of 4 parameters in the case of the clip tool. 3 of them are flagged by a small green dot, which indicates the parameter is required and needs a value, and thus there is no default value. These are the input features to be clipped, the clipped features, and the output feature class to store the result. The XY tolerance parameter is optional. The tool dialog box has several mechanisms for ensuring proper inputs. For example, you can type the path and a file name for input features. For example, see data stream .shapefile, but you can just as easily end up with a typo. But instead of typing a path and a file name, we can just click the drop-down menu arrow to select from a list of the layers in the table of contents in our current ArcMap document. So the arrow is shown only when there are acceptable feature layers in the map document to choose from. We can also use the Browse button to browse the data on disk. These options not only prevent typos but can check for valid data input. For example, for the clip tool, the clip features parameter has to consist of a polygon feature class, so the selection and browsing options will show only the available polygon feature classes. Another feature of the tool dialog box is that the content of the help panel change depending on where your pointer is. When the first open the tool, a description of the tool appears in the help panel. So if you're not familiar with the tool, this description is useful for ensuring you have the correct tool. Once you check inside the input area for a particular parameter on the tool dialog box, the content of the help panel changes to show an explanation of the parameter. For example, if we click the XY tolerance optional input data, a brief description is provided in the help panel. So alright. So this says the minimum distance separating all features coordinates as well as the distance a coordinate can move X or Y or both. Set the values to be higher for data with less coordinate accuracy and lower for data with extremely high accuracy. So to get back to the overview help, we click anywhere on the tool dialog box, but not inside any parameters areas. Now consider an example dialog box that has the parameter completed. The input feature class is a shapefile called road shapefile and is being clipped by a shapefile called zip code shapefile. So right now I don't have the data right now. The output feature class is a shapefile called road clip shapefile. Then the XY tolerance is left blank, which means the default value is used, which is 0.001 meters or its equivalent in map units for this parameter. So the full path to the output features is shown because the feature class was selected from disk. When selecting layers in the current ArcMap document using a drop-down list, only the name of a feature layer is shown and not its full path. In the later case, the file extension such as .shapefile is not shown because the parameter is specified as a feature layer, not as a feature class on disk. So let me put the data on exercise 1, exercise 2. Okay, roads. Okay, input folder connection, and it's in my Python data exercise 2. If I put roads, click add, and clip file, clip feature. That's my input feature. I didn't add data, and clip feature. I don't have a clip. Let me see results. Roads. Can I use soil shapefile? Alright, and then I'm gonna save it into Python exercise 2 results. Okay, click save. Roads clip. Alright, so the tolerance is here, and I'm gonna just click and run. Alright, so when I click and here it should pop up window when it's done running. We just have to keep an eye on it. So when we run the tool at the bottom of the ArcMap interface, a status bar displayed. Alright, okay, there, it's right here. The name of the tool that is being executed. By default, execution occurs in the background. This means you can continue working in ArcMap as the tool runs. When the tool is finished running, a pop-up notification appears in the notification area at the far right corner of the it's right here. Taskbar. When the tool is finished running, the resulting feature class is added by default as a layer to the ArcMap table of contents. When the tool is run within ArcMap, an entry is also posted to the result window on the menu bar. Click Geoprocessing, and we're gonna go to result. Will be weird. Okay. Alright, so this is the result. This entry includes all the input and output parameters as well as tool execution messages. The entry in the results window can be valuable in a number of ways. First, we can review the parameters that were used to run a particular tool. Second, we can run the same tool again directly from the results window. The tool dialog box can be populated with the same parameters as before, and we can use these same parameters or change selected ones. Finally, we can review any error messages in the results window. Take a moment to review the tool parameters on the tool dialog box. Parameters that are required and need a value on the tool dialog box have a small green dot next to them. So we can click the green dot to see more detailed information about the required parameter. Optional parameters have a no icon in front of them, and if they are left blank, the default values will be used when the tool runs. If an incorrect parameter is specified, an error warning appears. So pausing your pointer over the icon shows a brief description. When clicking, the icon brings up a more detailed error messages. In this case, the input data does not exist. Sometimes a warning message message appears indicating that running the tool may lead to undesired results. A warning message does not prevent the tool from running, but it may warrant taking a look at the warning prior to running the tool. In this case, the output data set already exists and